So we looked at the sine and cosine, and we're gonna now talk about graphing their reciprocals. And if you are, the reciprocals are actually not going to be too hard if you're good with the sine and cosine, because these are going to rely heavily on the graphs of the sine and cosine. So it'll give you more opportunity to practice your sine and cosine as we're going through this. But there's a few extra things we're going to add to it to get these graphs. Before we get into our notes, I want to show you what this looks like. I'm going to pull up a graphing program, and we're going to work through this real quick. I'm going to start with the cosecant function. So y equals the cosecant of x. That's what it looks like. Okay, so here's our, and it just repeats over and over and over again. Okay, so this is our cosecant function. It looks like it's made up of a bunch of happy and sad faces, or however you want to say that, right? It should be related to what function, though? The sine. This is the cosecant, so I'm going to graph y equals sine. And you can see a bit of connection there. Do that right there. Okay. So if you have a good sine function graphed, wherever there's a maximum value, it's going to touch the cosecant function, and wherever there's a minimum value, it's going to touch the cosecant function, right? Kind of right in the middle of the smiley face, right in the middle of the sad face, right? Shape. Also, what's happening here, and I'm going to point it out, wherever the sine function hits 0, for example, at pi or at 2 pi, if I drew those vertical lines there, so there's the green line right here is at pi, our cosecant function won't touch it. It'll just get closer and closer and closer to it, but it'll never hit it. And same idea here. And we call those vertical asymptotes. All right. Vertical asymptotes are things that give shape to your graph, and vertical asymptotes happen where the function itself is undefined. And let's talk a little bit about why that happens. So if I asked you last unit to find the sine of pi, and what would you give me? And you can even use the graph there if you want, but what's the sine of pi equal to? 0. Sine of pi is 0. So if I wanted the cosecant of pi, I need the reciprocal of 0. You remember what the reciprocal of 0 is? Undefined, right? And so when we're looking at a graph, where it's undefined is where you won't find a graph. And that's why we end up with these vertical asymptotes where it will never touch at those spots because it's undefined there. And as it gets closer and closer, it just shoots up higher and higher to positive infinity or down to negative infinity. Okay. Zoom out. Okay. And it just keeps looking like that. So there we have it. Zoom back in. Okay. So there's a whole bunch of red, but there's this gap in between. And that gap is between 1 and -1 in this one, right? There's no red in between 1 and -1. That's where the sine curve is. So let's try graphing some of these. Let's see what that looks like. Graph one period of y equals 2 times the cosecant of 3x. So if you're given a cosecant function or a secant function, the first thing you're going to want to do is to graph its helper function. And its helper function, what I mean by that is the reciprocal of it. So I'm going to just copy everything down, but instead of writing cosecant, I'm going to write sine of 3x. So I still have the same values, the 2 and the 3x, but I'm going to work with its reciprocal. And now I'm going to just take time and graph one period of that sine function. So we have its max and its min here at 2 and -2. I'm going to divide the x-axis into 4 equal quadrants. And plot one period of the sine function. It's a positive sine function. And this really isn't my goal. My goal is to draw the cosecant. So I'm just going to dash, or well, maybe I'll just use I'll use a light gray. I won't dash it, but I'll use a light gray just to say, hey, this is not the real thing. This is just helping me out here. Okay. And then need to label my x-axis. So I'm going to take 3x, my angle, and set it equal to pi over 2. Because that's I'm looking for the x value at the end of my first quadrant, and multiply both sides by 2 and get x is pi over 6. So my first x value, and then I'm going to increment by pi over 6. So 2 pi over 6, 3 pi over 6, and 4 pi over 6 are my values I'm going to label the x-axis with. And so this is what we would normally do with our sine curve. Nothing's new right now. So now comes a new part. Once you have a good graph of that, then you're ready to draw the cosecant. So wherever there's a maximum on my sine, I'm going to put a point for my cosecant and draw a happy face, right? Wherever there's a minimum, I'm going to put a point and draw that sad face. But I am going to keep in mind when I draw those, they cannot pass through these vertical asymptotes. And in one period, there's 3 of them right now. And there's my graph. So what are my equations of the vertical asymptotes? And here's how you spell asymptote. A-S-Y-M-P-T-O-T-E. Okay. So I have 3 vertical asymptotes that I highlighted. These are vertical lines that your graph won't pass through, but just gives shape, gets closer to it. What's the first one? X equals 0. Next one, x equals 2 pi over 6, which reduces to pi over 3. And the last one is 4 pi over 6, which reduces to 2 pi over 3. And these are actual equations of vertical lines. They're not just values, x values, but they're the vertical equations. What is the period of this function? How far along the x-axis do you have to go to complete one pattern? Is it right here at 2 pi over 6? Is that one pattern? No, because a pattern is happy, sad. And then repeat, happy, sad, right? That's a pattern. A full pattern, you need both the happy and the sad face. They're not really called the happy and sad face. I'm just... Okay, so it'd be 4 pi over 6, which is 2 pi over 3. Okay. And there you have it. Questions? Notice that there is a gap. And the gap is all y values between -2 and 2. And I'm going to write it this way. Right? So our our cosecant function will not take in any values between -2 and 2. There's this big gap in between. That's where our sine function would be. So our cosecant is everything above 2 and everything below 2 or equal to 2. But there's that gap there. And that's going to be important to notice as well. All right, so I'm going to give you an example that I want you to try. After you get a good graph of it, you have time, write the equations of the vertical asymptotes, state the period, maybe even state where the gap is. Okay. So number 2, here it is. Graph 1 period of y equals -3/4 cosecant of 2 pi x over 5. Just start that process. Do what you can, and then we'll work together on it. Okay. All right. So on this one, my helper graph is going to be y equals -3/4 sine of 2 pi x over 5. So work hard on getting a good graph for my sine curve. Work with the amplitude first, max at 3/4, min at -3/4. Divide into 4 equal sections on my x-axis. And it's a negative sine curve. So start at 0, 0 and drop down to its min. Start that process. And then working on the x-axis, I take my angle 2 pi x over 5 and set that equal to pi over 2. And then I'm going to multiply by a common denominator, which would be 10. So I'm multiplying both sides by 10, and I get 20 pi x over 5 is equal to 10 pi over 2. Only multiply the top part of that fraction. Then I'm going to reduce, and I get 4 pi x is equal to 5 pi. Divide by 4 pi. And I end up with 5 over 4. So that is my first x value, 5 over 4, and I increment by that, so 10 over 4, 15 over 4, and 20 over 4. Okay, so all this was to get a good graph of my helper function, sine. So now I'm ready to draw my cosecant function. So wherever there's a min, put a point and draw that sad face. Wherever there's a max, put a point, draw that happy face. Okay, and then don't forget there are these kind of boundary lines that you're not allowed to pass, called vertical asymptotes. Okay. So what's one period of this function? What is it? 5. Good. So you got 20 over 4, which is 5. Our vertical asymptotes, we got 3 of them. What are their equations? X equals 0, x equals 10 over 4, which is 5 over 2, and x equals 20 over 4, which is 5. Okay? And then there's this gap in between our smiley faces and sad faces, right? And that gap is in your y values, and I just want you getting used to writing it this way. So what's the lower value? Negative 3/4. And so this means all y values in between negative 3/4 and 3/4. Okay, so that's where our gap is. That's where the cosecant function is not. Okay. Question on that one. How'd you do? Yeah? Okay. Back to our function here. This time we're going to look at the other one, the cosecant. I'm sorry, the secant. And when we do the secant, what's our helper graph going to be? The cosine. So I'm going to graph the cosine first, because you know that's what we do, is we graph the helper function first, right? And okay, so there's our helper function. So do you have an idea what this cosine function is going to look like? Or sorry, the secant function is going to look like? We're still going to graph our cosine. Wherever there's a max, we're going to put a point and draw that happy face. Wherever there's a min, we're going to put a point, draw the sad face, and there's still going to be vertical asymptotes. So y equals the secant of x, right? So it just looks the same. Like if I zoom out, there you have it. You got the same shape. You got that gap in between still. Where would a vertical asymptote be? Anybody give me one of them that would work? I'll type it in. X equals what? Don't give me decimals. Give me exact values. What's that? 0? Where is that? Sorry. X equals 0. So you're saying it can't pass through that? Got to rethink that, huh? So x equals 0, let's take that back. Negative 2? Not quite, because it's going to pass through that right there, right? Let's try pi over 2. Okay, because that's the end of the first quadrant, right? That's where your cosine function's hitting the x-axis at 0, and the reciprocal of 0 is undefined. And so that's one of them. What's the other one? X equals pi? Let's see. Nope. 3 pi over 2 maybe? Let's try. Yep, found it. Okay, so things have shifted a little bit, right? Because that's sine and cosine, they're the same shape, but shifts of one another, and so are cosecant and secant. And so keep that in mind as we're working through these. All right, so let's look at the next example. We're going to graph one period of y equals -5 secant of pi x. I'll do this one with you. So first, our helper graph is going to be y equals -5 cosine of pi x. Okay, get the reciprocal of that function, get a good graph of that helper graph, and then you're pretty much done after that. So here's 5 for our maximum height, -5 for the min. Divide this into 4 equal sections here. And I'm going for the negative cosine. So negative cosine starts at the minimum on the y-axis and then goes to the x-axis to the max. Kind of get this upside down V shape. And then you draw the curve in there. Okay, so that's not my graph, but that's my helper graph, right? And I need my x values still. So I'm going to take pi x, set that equal to pi over 2, multiply by 2. Divide by 2 pi, and simplify, and I get 1/2. And I mark out my x-axis. All right, now I'm ready to graph the secant. So wherever there's a min, I'm going to draw a sad face, but the min is kind of like in the middle of that sad face, right? And so I'm only going to draw the right half of that sad face, right? If I kept going to the left, there would be some more, you know, I do have the full thing, right? But that sad face kind of starts in the middle of it, right? And then where there's a max, draw that happy face. And here's another min, but it's kind of that min is at the middle, or at the end, so I'm going to only draw the left side of that sad face there. And I have how many vertical asymptotes in this picture? Only 2, because there's only 2 x-intercepts for the cosine function right here. Okay. Again, just know if we kept going, you know, you would get that full sad face, but you don't have to draw that. In one period, you only get half. Okay, so our vertical asymptotes. All right, x equals 1/2, and x equals 3/2. The period of this function is what? 2. And our gap, go ahead and write down what the gap is. Use the right notation. What'd you write? -5. What comes next? Less than, what letter? Y, less than 5. Okay, good. All right, one last problem I want you to try on your own. Graph one period of y equals secant of 10x.